This episode of Thinking Through Autonomy is in partnership with the Eno Center for Transportation. Eno is an independent, nonprofit think tank focused on transportation. As an organization, Eno shapes public debate on critical multimodal transportation issues and builds an innovative network of transportation professionals. Eno's Aviation Working Group is a standing advisory group on all matters related to aviation policy. In their latest report, Bridging the Gap, Sustaining UAS Progress While Pursuing a Permanent Regulatory Framework, will inform today's discussion. Welcome to Thinking Through Autonomy, a podcast to help you understand the promise and impact of autonomous land and air vehicles in our world. I'm Ken Dunlap, managing partner of Catalyst Go, taking you on this journey. Hear and read more at thinkingthroughautonomy.com. Now it's time to take your hands off the wheel, foot off the pedal, hand off that throttle, and let's go. In this segment, we're talking with Stella Weidner. Stella is Director of Regulatory Affairs for Autonomous Systems Engineering at Boeing. Stella is a mechanical engineer whose career at Boeing spans materials technology, propulsion and design safety. She's a board member of the Royal Aeronautical Society's Washington, D.C. branch, and she's a guest lecturer at Duke University's Pratt School of Engineering. In this segment, we'll take advantage of Stella's unique perspective on UAS systems manufacturing and the unmanned industry in general. We'll build pictures of both the range of UAS programs Boeing is advancing and the many challenges associated with aircraft and production certification. Welcome, Stella, and thank you so much for sharing part of your afternoon with us.
Well, thank you, Ken, so much for having me. It's wonderful to be here and to have an opportunity to talk about some of these topics.
Well, the first thing I want to talk about with you, Stella, is your day job. You're Director of Regulatory Affairs for Autonomous Systems at Boeing, and I am wondering, what does that job look like? What do you do?
Sure, that's a great question. So my organization is Global Safety and Regulatory Affairs, and that exists within the Product and Services Safety Organization at the Boeing Company. It is an engineering organization that is focused on both internally, how do we design safe products, and also how do we engage outside the company. One of the themes that maybe we'll discuss today is the aviation ecosystem. And so much of the work that I do is representing that manufacturer's perspective within that aviation ecosystem. And I think maybe the word that I would use best to describe my day job is that of interface. When we think about the regulatory landscape, when we think about policy both domestically as well as globally, and trying to understand and contrast that with the needs and priorities of our business, you can intersect those two and from that, understand what are the challenges that not just we as a company face, but we as an aviation industry face. And more importantly, how can we, from that manufacturer's seat, how can we help address those challenges? So at a very high level, it is thinking about, again, that aviation ecosystem, our place as a manufacturer within that system. How do we enable safety? How do we advance the change and evolution of the system needed to accept the integration of unmanned systems, new operational concepts, advanced air mobility, all of these new technologies that we're conceiving of? How do we think long term about what will be needed to accommodate that integration? And what are the steps to get there? How do we work together? Because it very much is a collaborative effort between aviation industry, academia, government organizations, think about FAA, NASA, so on. It is a collaborative effort, and we really, in my office, Global Safety Regulatory Affairs, we are really at that intersection of representing our internal stakeholders and advocating on behalf of industry for that evolution that will be needed.
Stella, you used the word ecosystem a couple of times, and immediately in my brain I think, oh, well, that's got to be the FAA and maybe some other three-letter organizations, but When you sit down and you draw this big map in your office of the aviation ecosystem, who are some of the players on there that are critical to aviation safety in the national airspace system?
That's a great question. The entities that I think of, and some of them are organizational, some of them are individual. It can span that spectrum. I think of international regulatory bodies such as the International Civil Aviation Organization, ICAO, if you want to think at some of the top level, and then here domestically, of course, the FAA. But it's also spanning globally. We have a global airspace, and so we would be remiss not to mention EASA, our European partners, CASA, Australia, CAAC, China, all of those civil aviation authorities, and how we work together to manage our global airspace. From the industry side, we would think about manufacturers, we would think about operators, we would think about airlines, we would think about the supply chain, we would think about maintenance and repair organizations. And then at the intersection, there are service providers, air navigation service providers with air traffic control, air data providers. It is a very large constituency when you think about that aviation ecosystem. And the reason that I think that term is relevant and why I often reference it is because it is a way of understanding a shared responsibility towards safety. We have over many, many decades in the aviation industry achieved really high levels of safety, and that's been hard won. That learning has been advanced through accidents and incidents, often painful learnings. That has been codified into our Code of Federal Regulations. I think of that as, in many ways, a body of lessons learned representing, as an industry, as an aviation industry, what have we learned is important towards enabling safe outcomes. And that flows out into that aviation ecosystem constituency. What is the role of the manufacturer? What is the role of the pilot? What is the role of the operator? So on and so forth. And when we think about unmanned systems, increasing levels of autonomy, we are contemplating a significant shift in what that shared responsibility model looks like. And I think that is fascinating and is going to be some of the most interesting challenges in aviation that we've had in decades.
Let me ask you this, though. On the first day of the job, when you sat down and you said, okay, I'm going to be working on regulatory affairs, and you probably thought through the usual list of suspects of stakeholders in that ecosystem, are there any over the last several years that you worked with that were, hey, kind of a surprise? I didn't think I'd be working with them. Oh, I didn't know that they had a role. And especially, maybe when it comes to unmanned vehicles, who are some of the pleasant surprises of organizations that you had to deal with? And you don't have to, mention the organization by name, but just kind of wondering.
Absolutely. Taking this role on has been a period of surprise and learning for me on a very personal level. I think that this industry has attracted the attention of organizations that have not traditionally been a part of aviation. And I think that is a big part of what makes this such an exciting space. There are organizations and individuals who have come from other industries, who have brought different philosophies about how to bring products and services to market, and they are applying that to aviation. It has been, in some ways, surprising in a wonderful way, but also challenging. Aviation is, as we mentioned, decades old. It has traditions that are entrenched. Some of those, the reasons for which are lost in the fog of time, but they're often related to some of those painful learnings that I described earlier. Often we do things the way that we do as a result of learning that's what's needed or is a way to prevent a bad outcome. And so the regulatory process is deliberative and slow and thoughtful and invites wide-ranging engagement. And there's pluses and there's minuses associated with that. And so to inject this different philosophy that often comes from, we see the Silicon Valley types, we see some of those perspectives from kind of new technology domains coming into this, kind of old school industry. And it is just a fascinating intersection, sometimes of conflict, but often I think of opening our eyes to new possibilities and new ways of doing things.
Stella, when I think of Boeing and I think of unmanned systems, one word pops into my head, and that's Scan Eagle.
Yes.
But I have to think that that's only a small part of the picture in unmanned autonomous vehicles. What does Boeing's picture look like? What's in that catalog? What can I buy on the internet at Boeing.com?
That's a great question, Ken. I think that people might be surprised at some of the products and services that we're contemplating. When a person thinks of Boeing, they perhaps think of the iconic 747 or perhaps some of our defense and space products. But in this space, in this innovative space, we are looking at the full range of opportunity that these unmanned systems and this increasing level of autonomy offers. It could be new technologies that enable better safety on our traditional products. It is often things like you mentioned, the Scan Eagle, historically a defense product that we're looking at commercial application for, survey. But we're also considering things such as freight, last mile delivery, ultimately passenger carriage. And it's in sizes and range and models that are unlike anything that we've necessarily done before that people might be familiar with. One of the really exciting things that you may be aware of is our cargo air vehicle platform.
I've heard of that.
Yes, which was used as the platform for an X-Wing fighter demonstration that was done at Walt Disney World last year.
Ooh,
you can find the clips on YouTube. But it was when I first saw the concept art around that, I said, this may be the most exciting thing I've ever worked on at the Boeing company. It was just so cool.
So let me follow up on this, Stella, because as you know, I'm not from the manufacturing world. But I would like to think that a major manufacturer like yours just doesn't sit around and say, hey, let's go build something because we can. There has to be a business case associated with that. And I'm just wondering from the business perspective, how do those use cases that you talked about get identified? And do you develop some of those natively? So you can say, okay, people might not be thinking about this, but we can bring this new technology out there. How do you associate a very expensive airframe to make with a business case?
That's a great question, Ken. And I think that is one of the things that perhaps differentiates Boeing's approach from others that are working in this space. We are, in fact, not focused on the business case here in the near term. We believe this represents a major shift in aviation, and what we are focused on right now is learning how to do this safely, understanding what are the challenges that we face as an industry. How do we, from that manufacturer's seat, how can we help solve those problems? How can we learn through doing? And That is a comprehensive approach. We believe that we will learn things through platforms such as the Scan Eagle and other smaller, less complex, lower risk types of operations that will then inform the next step of larger vehicles, more complex operations, and then ultimately having the confidence that's built on data, that's built on knowledge gained through flying, of moving on to what I think we all ultimately have in mind, which is commercial passenger service. That's out in the distance though, and what we've got our eye on right now is that learning journey and how we can move from one step to the next and grow our capabilities in a scalable way.
Which is a perfect segue to my next question. At the top of the segment, I mentioned that you're a guest lecturer at Duke University's Pratt School of Engineering. So you get to see the next generation of ambitious mechanical, structural, electrical, aeronautical engineers. Can you let us know just a little bit, how tough of a proposition is it to go to a student and say, you should really get involved in autonomous technology. You should get involved in aviation technology. How do you pull that student into the realm of aviation when there's so many other exciting choices out there?
You know, that too, you ask a lot of great questions, Ken.
Well, thank you.
And you know what what I have found in my own personal observation is that there there are so many bright, smart, driven young people out there going through their education who are looking for what is it that they want to do? Where do they want to apply all that talent? And what I would offer is amongst that pool, there are those who are really excited about aviation, and I don't have to sell them anything. I just tell them my story. I connect them with what a company like Boeing does, and it sells itself. There are a lot of potential opportunities for individuals in STEM fields, but there are absolutely those who just will be drawn to aviation, to aerospace. We have within aerospace some of the hardest problems that exist. And I tell you, there is nothing in my experience that an engineer loves more than a hard problem to solve, unless it's something broken that they want to try to fix.
Okay.
So, honestly, just in summary, aviation and aerospace, they sell themselves. And that's who we're looking for. We're looking for somebody that's got that passion. They will bring their best selves to the work. They will bring that bright talent to solve some of these problems with us.
Stella, let's maybe now change the focus of the conversation and start talking about safety, which I know is a topic you are passionate about and has been an integral part of your career. Certainly, we have new engineers who need to be taught about a culture of safety. We have new companies, these new entrants into the unmanned world, who may not have appreciation, as you pointed out earlier on, for the lessons that aviation has learned over the years. Foundationally, how do you integrate safety into this unmanned industry? What do people, what do companies, what do the engineers need to be thinking about when it comes to safety of unmanned vehicles?
Yes, you're right. It is, we've talked a little bit about that intersection of non-traditional companies and individuals who have been attracted to aviation by some of the promise that autonomy seems to offer. And into that same space, we are bringing traditional aviation concepts and approaches. And so how do we marry those together? That's, I guess, the question that I heard, and it's an excellent question. And really, I think it has to do with shared learning. I talked about how Boeing is taking a learning approach, and I would offer that that is something that we would advocate for universally as we consider, how do we introduce UAS into our airspace, into our global airspace. When we think about safety, the outcomes that we enjoy today in aviation are the result of decades of learning. When we think about our Code of Federal Regulations, that's a resource for us. It represents a means of understanding how we can enable safety. Now, we recognize that those regulations and their companion requirements that exist. A company like Boeing or any manufacturer has their own set of requirements that they internally levy on top of regulation, as do operators and airlines and other entities within that aviation ecosystem. But we recognize that those requirements will need to evolve. They were predicated on the idea that you have a human person sitting in a cockpit on an aircraft. And there are a lot of concepts looking at changing that model. And so we will, I believe, in the years ahead, reach a new, if you will, equilibrium within the aviation ecosystem that accepts those different models of human machine interface. And it will be the process of getting there. So that process of getting there, we want to take in the new ideas and the new approaches from, I'll say, non traditionally aviation companies, but I cannot understate how important I think it is that we embrace the lessons that have been learned from traditional aviation, both commercial and general aviation, over these past many decades. It is that knowledge, that foundation that will enable us to do this safely. And any other outcome it's unacceptable.
So, Stella, is it fair to say that the traditional manned aircraft industry and this brand new unmanned industry can do a lot of sharing, because in the end, they both need to have the same goals, that there shouldn't be safety goals for the unmanned world versus safety goals for the manned world, that there needs to be literally a common vision?
Absolutely. It is a shared common airspace. It is a resource for all users, whether that be traditional aviation, whether that be this new unmanned systems, whether it be amateurs and hobbyists. It's a shared resource. And so we are all invested in ensuring that we have those safe outcomes. I think the flying public certainly expects no less from us.
Understanding risk and understanding how to mitigate those risks, that seems to be the lifeblood of safety. And I'm wondering, how should we approach dealing operational capabilities, manufacturing processes that don't have any analog in what we call traditional aviation?
It's a big challenge. One of the examples perhaps that we can draw on is the concept of collision avoidance, which in today's environment, we draw on technology solutions as well as human performance solutions in order to meet that objective. When we no longer have a human pilot sitting on an aircraft, what does that solution look like? It will change. And that is perhaps a very good example of some of the challenges that we have going forward when we think about unmanned systems. How do we solve that problem in a different way with solutions we have and new solutions that we'll need. How do we certify that? How do we validate that? How do we have confidence that that solution will provide for the safe outcomes we demand? And how do we do that both from a technology standpoint, but also from a regulatory through a regulatory lens. It's not just the technology itself, it's demonstration of the reliability and performance of any solution that we would develop, we as an industry. I think that's one of the challenges that really speaks to your question. I think what we have a toolkit. Although some of the technology challenges may be new and novel, we have existing tools in our toolkit that can help us do this. You're probably familiar with Safety Management System, SMS, and that, although it has an acronym and so may sound like a daunting concept, it is in fact a very accessible and approachable way of thinking about exactly what you described. How do we solve new and novel challenges? How do we understand the nature of the risk that it poses, the risk that will be experienced by other users within the system? How do we mitigate that risk? How do we understand whether our risk mitigation was effective? And how do we continuously improve? Those are all the philosophical underpinnings of a safety management system. That is something that is being advanced across organizations, manufacturers, operators, regulatory agencies. And I think within that lies the tools that will help us solve some of these problems.
And SMS specifically was the focus of several recommendations that the Eno Center made in their Bridging the Gap report, which was released on August 28th. You used the word certification, though. And I am wondering, why would you need to certify an unmanned aircraft? What do you get out of certifying an unmanned aircraft that you wouldn't get just say if you built it and chose to fly it?
Absolutely. And in the near term, in the learning days, there are options other than certification that might be best for what you are trying to do. If you are indeed trying to learn through flying, it may be that a type certification is not what you need. But ultimately, our aspiration is full integration into the airspace. And for that, I would offer we need the additional rigor that type certification provides. The internal processes that are driven by certification, the regulatory engagement and oversight that it invokes, that leads to the safer outcomes that we as an industry demand that the public expects. And so while it may not be the first step, I do absolutely believe that type certification is the final necessary step to full integration.
And for those folks that are listening to this segment, I think they might understand certification through the process that they might be familiar with when they get onto a commercial airliner or a business jet or a general aviation aircraft. And that's the manufacturer and the FAA work together to make sure that, almost down to the bolt, that the parts are correct, that the parts function the way that they're supposed to. Is that the same kind of paradigm we're talking about for unmanned aircraft, that we're going down to the bolt level to make sure that everything checks out and everything is safe?
That's a great question, and I think it depends on what you want to do. If you want to carry passengers into controlled airspace, then I think the answer is yes. However, if you are looking at less complex operations, so not full access to airspace, but are willing to accept limitations on your operations, which may be perfectly suitable for whatever it is that you're trying to do, then that level of certitude may not be necessary. And so that it's that interplay between what is the risk and complexity of your operation and how do you match that with the performance and certitude of your platform. And so I think that interplay is what allows for the myriad of operational concepts that are being considered from the portfolio of advanced air mobility, people delivering medicines, the air taxis that we're talking about, into the more traditional freight and long distance passenger carriage. And so there's a continuum there marked by that interplay of what is your operation and what then do you need the capability of your aircraft to be? And how well do you need to validate the capability of that aircraft as represented by certification?
Based on what you just said, I would have to think that aircraft and production certification winds up being a very large portion of your day job. And what I'm wondering, Stella, is as you look and you look at this longer time frame that you've discussed earlier on in the segment, what do you see as opportunities and challenges for unmanned manufacturers when it comes to the certification process?
I think one of our biggest opportunities, and we've certainly seen a response within industry and within regulatory and other governmental partners towards this opportunity, is increasing access to airspace for demonstration and conceptual operations done in a safe manner. That ability to learn through flying is so important to gaining the data, gaining the understanding, to be able to move towards some of those more complex operations that we've talked about that would happen in populated areas, over people, potentially with passengers on board. And there is, in many ways, no substitute for the actual flying itself. And so to enable that testing and learning portion through access to airspace, through experimental certificates, I think that is one of the key unlocks in the near term to really helping this industry to progress.
As I think about all the flight testing that needs to be done on a unmanned system, are you finding right now that it's easy to get access to the airspace? Is it easy to get the approvals that you need to? And I would suspect that gets compounded by the fact that you probably can change the design at an incredibly fast pace as you develop these vehicles.
I think there are still challenges with getting the necessary approvals to access airspace. And I say that understanding the reasons for those challenges. This is new, and we are a thoughtful and deliberative industry that's focused on safety. And so, in many ways, although we might want to move faster and would certainly advocate for improvements to the processes and mechanisms that allow access to airspace, we certainly respect and understand why we are experiencing a pace that is perhaps slower than we might like. And it really is because we are learning as an industry, and by that I don't just mean the commercial industry, I mean we are learning across the breadth: government, academia, traditional industry, new entrants. We are all learning, and to some degree we need to come along together. It needs to be a learning journey together, so we bring everyone along. There is an individual, you may know her, Anna Dietrich, who once described this problem as not just Sisyphus trying to push the boulder up the hill, but instead trying to push 30 rocks up the hill, all at roughly the same time. And I loved that analogy. I think that's where we're at. We need to bring everyone along at roughly the same pace for this to work. And so each step, slow though it might be, is an accomplishment in bringing people along on that learning journey.
Stella, in the last couple of minutes we have together, I just want to focus on maybe two issues that we really haven't quite touched yet, but I know are important in the unmanned industry. The first one is spectrum. We talked about flight testing, But we also understand that there's a pilot on the ground that's responsible for monitoring and operating many of these unmanned systems, and that requires radio links. And it's radio links to operate, radio links to take the data down so we can understand what the vehicle is seeing, how it's operating. Have we cracked the nut on that? Have we solved all the problems with Spectrum? Or are there issues out there that kind of remain important and yet untouched?
I am so glad you brought up Spectrum, Ken. I cannot understate the criticality of access to aviation safety spectrum for this nascent industry. It will not be possible unless we have access to that safety spectrum. It is, as you described, the means by which a remote pilot controls, commands, communicates with the aircraft. It is the mechanism that underpins concepts for unmanned traffic management systems, for centralized air navigation services to be able to communicate with pilots, with aircraft, for aircraft to be able to communicate with each other. To be able to safely advance this industry, we will need the allocation of aviation safety spectrum. And that is not a solved problem by any means. That is a problem that is front and center for the industry to collaboratively solve with our partners at the FCC, with our partners at the FAA and the Spectrum Office, and with many others, quite frankly. There are many, like airspace, Spectrum is a shared resource. And working through how we will share that resource in a way that enables this industry to really take off, for the promise to come home, is something that is very much on our minds here at Boeing.
Finally, Stella, understanding that Boeing has a rich tradition in unmanned military aircraft that most likely have capabilities in the civilian world, can we kind of close understanding the challenges that manufacturers face when they try to convert something that has successfully and safely been used for the military into a vehicle that can successfully and safely be used by civilian operators?
Absolutely. There are, in my mind, maybe two ways to think about those challenges. One of them is very simply our export control requirements, something that is designed for our military customer by necessity. Has restrictions on the design and exportability of that aircraft in order to preserve security concerns. So to simply take a military aircraft and apply it for civil use is not a natural path. You really do need to start with a commercial intent in your design if you are going to offer it for those purposes. Now, that said, you can still absolutely bring to bear all the experience and learnings that you've had through developing and operating a military aircraft when you consider that civil design. So that's probably one aspect. The other aspect is that typically in a commercial concept for an aircraft design, you would historically start at a very early stage with a good understanding of what your requirement set is going to be. And that would inform your design from day one. When we think about military application vehicles being turned to commercial application, we are in many ways starting with a mature design concept, and yet the requirements basis, because of the nature of it being UAS and the fact that our regulatory framework is still evolving to capture unmanned concepts, there is an entire set of requirements that is still not well understood. And so in many ways you are working in the dark in terms of understanding through that requirements life cycle what are the starting seeds from which you then grow whatever your aircraft design will be? And so it ends up being a working backwards exercise of trying to demonstrate through operations, trying to demonstrate through history that you are both developing the requirement set and proving that you meet the requirement set at the same time. And that is a challenge that that really is in many ways unique to unmanned systems because of the novelty of the operational challenges, the novelty of the technology. That development of that requirement set is a huge challenge to any attempt to convert a military use aircraft to a commercial aircraft. So that combined with the export control issues is really presenting some hurdles to overcome. However, I do think that it also provides the advantage because we have that deep history. It will help us going forward on developing that appropriate requirement set that will then be of use not just to military derivative aircraft, but all free designed, blank white sheet designed commercial UAS.
Stella, on that note, I want to thank you so much. This has been an incredible conversation. We have not even touched underwater vehicles and space systems, and hopefully we'll have the chance to talk about that soon. Stella, thank you so much.
You're welcome, Ken, and thank you in turn for having me here today. This was a delightful conversation. I really enjoyed our time together.
This podcast is edited by Piper Creative. Piper works with startups, Fortune 500 companies, and everyone in between to produce podcasts, YouTube videos, and compelling digital media. Learn more at pipercreative.co.